Understanding how the brain interacts with emotion offers profound insights into human behavior, cognition, and mental health. At the heart of this intricate relationship lies a network of neural circuits and neurotransmitters that orchestrate our emotional experiences. The limbic system, often considered the brain's emotional center, plays a pivotal role, with structures like the amygdala, hippocampus, and prefrontal cortex collaborating to process and regulate emotions. Sensory input from the environment triggers cascades of neural activity, leading to the interpretation of emotional stimuli and the generation of appropriate responses. Furthermore, neurotransmitters such as serotonin and dopamine modulate our mood and emotional states, while neuroplasticity enables the brain to adapt and rewire itself in response to emotional experiences. By unraveling the complexities of brain-emotion interactions, we gain deeper insights into the human psyche and pave the way for advancements in mental health research and treatment. Number 8. Limbic system. The limbic system serves as a pivotal hub for processing emotions within the brain. It encompasses several key structures, including the amygdala, hippocampus, hypothalamus, and cingulate gyrus. Among these, the amygdala stands out as a central player, exerting significant influence over the processing and regulation of emotions, particularly those related to fear and pleasure. Its intricate connections with other brain regions allow for the assessment of emotional significance in various stimuli and the initiation of appropriate behavioral and physiological responses. Through its interactions with the broader limbic system and cortical areas, the amygdala contributes to shaping emotional experiences and guiding subsequent behaviors. Number 7. Amygdala. The amygdala, a small but powerful structure nestled deep within the brain's temporal lobes, serves as a central hub for processing emotions. Like a vigilant sentinel, it swiftly evaluates incoming sensory information for emotional significance, particularly concerning fear and pleasure. When confronted with potential threats, such as a sudden loud noise or a menacing figure, the amygdala triggers the body's fight-or-flight response, orchestrating physiological changes like heightened heart rate and increased alertness to prepare for action. Conversely, in moments of joy or reward, the amygdala contributes to feelings of pleasure and motivation, reinforcing behaviors associated with positive outcomes. Furthermore, the amygdala plays a vital role in forming and storing emotional memories, shaping future responses based on past experiences. Its intricate connections with other brain regions enable nuanced emotional responses and facilitate social interactions, making it a cornerstone of our emotional experiences and behaviors. Number 6. Hippocampus. The hippocampus, nestled deep within the brain's temporal lobes, plays a crucial role in the intricate dance between emotion and cognition. While often associated with memory formation and retrieval, the hippocampus also contributes significantly to emotional processing. It acts as a bridge between past experiences and present emotions, helping to contextualize and interpret emotional stimuli. Through its connections with the amygdala and other limbic structures, the hippocampus influences the encoding and storage of emotionally charged memories, shaping our responses to similar situations in the future. Moreover, research suggests that the hippocampus is involved in regulating stress responses, with alterations in its function linked to mood disorders such as depression and anxiety. In essence, the hippocampus serves as a linchpin in the brain's emotional landscape, weaving together memories, emotions, and cognitive processes to guide our behavior and subjective experiences. Number 5. Prefrontal cortex. The prefrontal cortex, situated at the front of the brain, is instrumental in governing our emotional responses and social behaviors. Often regarded as the seat of higher cognition, this region plays a pivotal role in regulating and modulating emotions. Through its intricate connections with limbic structures like the amygdala, the prefrontal cortex exerts top-down control over emotional impulses, enabling us to regulate our reactions in accordance with social norms and personal goals. Moreover, the prefrontal cortex is involved in decision-making processes, weighing the potential outcomes of different courses of action and guiding behavior accordingly. Its functions extend beyond emotion regulation to encompass working memory, attention, and executive functions, allowing us to adapt flexibly to changing environmental demands. Dysfunction in the prefrontal cortex is associated with various psychiatric disorders. Number 4. Neurotransmitters. Several neurotransmitters, including serotonin, dopamine, and norepinephrine, are crucial for modulating emotions in the brain. Serotonin, often associated with feelings of well-being and happiness, helps regulate mood, sleep, and appetite. Dopamine, known as the feel-good neurotransmitter, plays a role in motivation, reward processing, and pleasure. Norepinephrine, also known as noradrenaline, influences attention, arousal, and the body's stress response. Imbalances in these neurotransmitters can disrupt the delicate balance of emotional regulation, contributing to mood disorders like depression and anxiety. For instance, reduced levels of serotonin are linked to depressive symptoms, while dysregulation of dopamine can lead to mood instability and anhedonia. Similarly, alterations in norepinephrine levels are associated with heightened arousal and anxiety. Understanding the roles of these neurotransmitters in emotional regulation is critical for developing targeted treatments for mood disorders and promoting mental well-being. Number 3. Neural pathways. Emotions are intricately woven into the fabric of the brain through a network of complex neural pathways that connect various brain regions. Consider the simple act of seeing a loved one. This sensory input initiates activity in the brain's visual processing areas, where the image is recognized and processed. From there, the information is relayed to emotional processing centers, such as the amygdala and prefrontal cortex. The amygdala quickly evaluates the emotional significance of the sight, determining whether it elicits feelings of joy, comfort, or any other emotion. Simultaneously, the prefrontal cortex comes into play, helping to regulate and modulate these emotional responses, perhaps guiding behavior or influencing subsequent thoughts. This intricate interplay between sensory perception, emotional processing, and cognitive evaluation underscores the complexity of how our brains generate and experience emotions. Number 2. Feedback loops. Emotional experiences often set off feedback loops within the brain, creating a dynamic interplay between our emotions and neural activity. Take, for instance, the experience of a positive emotion. When we encounter something rewarding or pleasurable, such as spending time with loved ones or achieving a personal goal, the brain responds by releasing neurotransmitters like dopamine. This surge of dopamine not only amplifies the sensation of pleasure but also reinforces the neural pathways associated with the positive experience. As a result, the brain becomes primed to seek out similar rewarding experiences in the future, creating a feedback loop that strengthens our emotional responses and behaviors. This process highlights the intricate relationship between our emotions and brain chemistry, shaping our perceptions, motivations, and overall well-being. Number 1. Plasticity and learning. The brain possesses remarkable adaptability, constantly reshaping its structure and function in response to experiences. Emotional encounters, in particular, wield significant influence over this process through a phenomenon known as neuroplasticity. This means that our emotional experiences can sculpt the connections between neurons, altering the way information is processed and stored in the brain. Moreover, these experiences can even induce physical changes in the brain's anatomy, reflecting the profound impact emotions have on our neural architecture. In essence, our brains are dynamic organs, continually evolving as we navigate through life's emotional landscape. This adaptability underscores the brain's capacity for growth and change, providing a mechanism for learning, adaptation, and resilience in the face of emotional challenges. Thanks for watching. Subscribe to the channel and hit the bell icon.